Today's lesson is about differentiating between standard and scientific notation and then converting back and forth from standard to scientific or scientific to standard notation. Standard notation is when the value is written out in long form, much like you learned when you first learned how to write out numbers. So I have two different examples here. I have 397,210,515 and 0.00019210. So both of those are considered standard notation. Scientific notation is where we take a value and we write one number, the decimal point, all other significant digits, and then we do times 10 to some exponential value based on how many placeholders we need to indicate. So I have two examples here. I have 9.28102 times 10 to the fourth. So what all of this indicates here, the 9.28102, those are all significant digits. When we convert this from scientific notation to standard notation, every one of those values must be written. It's a positive exponent, which means it's a number greater than 1. The second example, 8.6411 times 10 to the negative 7th, there's a negative exponent, which means we have a number that's greater than 0, but less than 1. Now, in both of these, as in the standard notation examples, there was a space in between the digits after every thousand or thousandths place. The space is done in lieu of a comma to avoid misinterpreting a comma as a decimal point. So we're going to first convert from standard to scientific notation. When you're converting from standard notation, to figure out what digits you write, all of your non-zero digits will be written, and then any trapped zeros will also be written. Whether we write trail zeros or not, that will be taught in the lesson based on significant digits. So in this, because we start with a non-zero and we finish with a non-zero, when we write this in scientific notation, all of those values will be written. Now, how we write it is you're going to start with your largest value, which is your 9. So we're going to put our 9, and then we put our decimal point because it's one number, the decimal point, then all other significant digits. So we wrote our 9, and we already established that all of these other values also have to be written. So we're going to just fill those in first, and then we'll figure out our exponent. Now for our exponent, you start either where the decimal is or where the assumed decimal would be if there is not one present. And you count over until you're at that last number. So we go over 1, 2, 3, 4, 5, 6, 7 places. So our exponent is times 10 to the 7. For the second example, it's going to be a negative exponent because we're at a number between 0 and 1. So same thing, you go to your first available non-zero digit, and that will be the number, the first number that you write before the decimal point. And again, all other values after that must be written. And I'll explain the zeros again later in a different casting. So now with a negative exponent, this first 0 here is just there to say, hey, there's a decimal point. It actually serves no other purpose. These other two zeros before the 2 are placeholders. So we're going to move 1, 2, 3 until we're behind our first value. So our exponential part of this is going to be to the negative 3. Okay, so now the last example is going to almost sound like it contradicts the previous one. So I want to talk about the 0 just a little bit. This 0 was an estimated value. So on this scale, we measured all the way over to this point, and then we said it was sitting exactly on the line. This 0 here is not trapped, so there's no decimal, there's no other digits. It's not in a measured place. If you don't understand that, don't worry about it just quite yet. We're going to get to that in the significant digit lesson. So here's our first non-zero, or our largest value in that. So we're going to write 4 point. And then in this one, we're not going to include the 0 because it's not trapped. It's just a placeholder. So we're going to do 4.6285. But then as far as our exponential place, we go from where the decimal point is assumed to be, which would be here, and we move over 1, 2, 3, 4, 5 places. So we're going to go 10 to the 5th. Okay, so when it's a number greater than 1, you start from the decimal or the assumed decimal and count over till you only have one value left. That's your exponent, as in the first and the third problem. And then you write all of the other non-zero digits trapped 0 or trapped zeros. And then when you don't have the trapped zeros, as in the last one, you leave it off because it's a placeholder. For your numbers less than 1, you start from the left side and you go till you get past the first non-zero digit. That's your largest value, or the number that's in your largest place. That's written first, decimal point. And then when it's a number less than 1, all of the other digits after it get written. And now to convert from scientific to standard. When a value is written in scientific notation, every single digit is considered significant. So every single digit that's written before the time sign must appear in the standard notation format. So our first one is times 10 to the 3. This is how many, and it's a positive 3. So this is how many places to the right we are going to move our decimal point to get our value. So we're going to move it over 1, move it over 2, move it over 3. So our value becomes 8436.10. Now with a negative exponent, it's how many places to the left we will move our decimal point. So we would go over 1, 2, 3, 4, 5. So what that means is we're going to have 0. Remember, this first 0 just says there's a decimal point there. So 1, 2, 3, 4, 5, and then the remaining value. Or another way to think of it is, because my exponent is 6, one of those 6 places is my 3, which leaves me 5 zeros to put before the value. In this last example, there's a negative sign. That just means if we were on a timeline, we're on the bottom side or the back side of the timeline. So that goes there regardless. It just tells us which direction. Positive 4. And so because it's a positive exponent, we're going to move our decimal to the right. So we're going to go over 1, go over 2, go over 3, go over 4. So we're going to write 2918. Let me erase that because I messed up. Sorry, guys. We're going to write the negative, and then we moved it over, so we're going to do 29182 point, and then you write all of the rest of the values, 0.1038. I hope this helps.